This is our first lesson on our module 2, which is on symmetrical components. So this part of the lesson really is going to introduce the concept of symmetrical components. These are used when we are talking about faults in a system. So we've already now introduced our three-phase systems, and they mainly looking at your transmission lines. And so therefore, when we have faults in those systems, this shows us how we break up the system so that we can be able to work out what are the currents and the voltages that are now involved within that system at the time that the fault occurs. So the first fault that I'm going to introduce to you very quickly is when we're talking about symmetrical faults. Now, funny enough, your symmetrical components don't talk to symmetrical faults because your symmetrical faults are balanced faults. In other words, all of your phases have got the same current and the same voltage across, which is 120 degrees apart. And your power system can be treated as only one system onto it, where you look at just the one phase and be able to multiply that by 3 to get what is happening on all of your other two phases. When we talk about unbalanced fault, we are referring to now an unsymmetrical fault, which means you have either a fault happening on only one phase or two of the phases, but it's not happening on all of your three phases at the same time. So it means that your line currents in that scenario become unbalanced into your system, and the displacement between them is no longer fixed at 120 degrees. So for your unsymmetrical, it applies only when the fault is actually occurring on your system. If there's no fault in your system, then you do not have unsymmetrical situation that is going to apply in there. So the system impedances and voltage sources are always symmetrical through your main elements, which is your generators and your transmission lines. And then an unbalanced three-phase is actually equal to a sum of three sets of balanced or symmetrical components. That's where the word comes from on the symmetrical components. Just to summarize that slide previously is that your symmetrical components, we utilize them to analyze a fault that is occurring on your system so that we can be able to understand what is happening with our line currents and our voltages. It converts a three-phase unbalanced system into three sets of balanced systems or balanced components, and those are called symmetrical components. In the previous chapter, I explained how you can be able to establish what a positive phase sequence is. So what I want to tell you now is that the positive phase sequence is part of your symmetrical components that you would get. So what you have there is that although you've got the three sets of symmetrical arrangement phases, you've got the positive one, which is our PPS, where a system of equal phases is 120 degrees apart. And when you rotate it through the dot that we are now familiar with, it will go into the phase of ABC through it. This means that the phases will pass through that circle in that sequence of ABC. So this is the first one. Then the is when we're looking into our negative phase sequence. So for our negative phase sequence, we also know that we'll pass through that dot at CBA or what we call ACB through that dot point. So this is also an equal system phases, and they are still 120 degrees apart. It's just the way that they pass through that dot that is now different. Then we look at our new one that we haven't seen before, and this one is called your zero phase sequence. So in your zero phase sequence, you will find that your phases, they are equal in magnitude, but they no longer have got that 120 degrees apart from them. So instead of what you have is that now they are coincident, which means that they are exactly at the same angle. So this is a symmetrical system as well, since your phasors are equal in length and the same angle displacement is across all three of them. However, because your resultant in your system is unbalanced, it cannot be a zero, then this makes this zero phase sequence an unbalanced one from your other negative and positive, which are symmetrical and balanced. Here is all three of them put together for you. And these we call our symmetrical components. So whenever you have an unbalanced fault on your system, the system will result into three symmetrical components, okay? Your positive, your negative, and your zero phase sequence. So we are going to now look at if we have a system and we've used a balanced system so that we can be able to explain the concept better. So we're going to introduce a phasor that we are going to call alpha. And this alpha is really going to be at 120 degrees. So if we look at your phasor diagram that you have there, which is an ABC diagram, at A, if I had to have an EA over there, then my EA I can say is at 0 degrees.